Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 1 of 5 good problems on the chapter of polygons. I have recently completed the chapter of polygons from the textbook of author R.S. Agarwal in the other playlist, that is CBSE Maths 8 R.S. Agarwal. If you have not watched those videos in that playlist, I strongly suggest and request that you please watch those videos first to have a good understanding and foundation of the chapter concepts, and then try to solve these 5 good problems. So this video is part of the playlist Maths 8 Hot, where HOT stands for High Order Thinking Problem, and where I come up with relatively harder problems from every chapter as and when they are completed from the other playlist, that is CBSE Maths 8 R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 1 on the chapter of polygons. Okay, so I have the problems, 5 good problems of set 1 on the left hand side. On the right hand side, I will solve the problem. I hope the fonts of the problems are big enough so that you can see them properly. The link of the PDF version of these 5 problems will also be there in the description below. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. So let's get started in solving the problems. The first problem says that P1 and P2 are two regular polygons with P2 having double the number of sides as P1. E1 and E2 are the exterior angles of P1 and P2 respectively, such that E1 plus E2 is equal to 90 degree. Then P1 is a pentagon, triangle, hexagon, octagon. Okay, so it is asking about what kind of polygon is P1. That is, it is asking how many, what is the number of sides of the polygon P1. Now, P1 and P2 both are regular polygons, and it is given that the number of sides of P2 is double the number of sides of P1. Okay, and if E1 and E2 are the exterior angles of P1 and P2, their sum is equal to 90 degree. Okay, so um, let's assume the number of sides of P1 and P2. So let N1 and N2 be the number of sides of P1 and P2 respectively. Okay. Now, since P1 and P2 are both regular polygons, we can say that each exterior angle of P1 will be equal to 360 degree by N1, which is equal to given as E1. Similarly, we can say 360 degree by N2 is equal to E2. Now, also it is given that the sum of E1 and E2 is 90 degree. So, E1 plus E2 is given to be 90 degree. This implies if we add, so E1 is 360, actually this is 360 by N1, this much degree, plus 360 by N2, this much degree, will be equal to 90 degree. Now we can ignore the degrees, and if we take 360 common from the left hand side, we get 360 multiplied by 1 by N1 plus 1 by N2 is equal to 90, and furthermore if you divide both the sides by 90, we get 4 multiplied by 1 by N1 plus 1 by into is equal to 1. So we have this, or we can say 1 by n1 plus 1 by n2 is equal to 1 by 4. Now it is given that P2 has double the number of sides as P1. So we can say, as per our assumption, we know that n2 will be equal to 2n1. Since it is given n2, we have assumed n2 to be the number of sides of P2 and n1 to be the number of sides of P1. And it is given that P2 has double the number of sides as P1. So we must have n2 is equal to 2n1. So now we get 1 by n1 plus, instead of n2 we will write 2n1. 2n1 is equal to 1 by 4. Simplifying the left hand side, we get 3 by 2 n1 is equal to 1 by 4. This implies n1 is equal to 4 multiplied by 3 by 2, this is 6. So n1 is 6. It is asking about P1. Okay, so n1 is 6. N1 is 6. So definitely we will have, this implies P1 is a regular hexagon. P1 is a regular hexagon, since it is already given P1 and P2 are regular polygons. So therefore the correct choice is hexagon, that is choice C. Okay, let's do question number 2. The correct definition of a polygon is, the choices are a curve formed by line segments. Choice B is a closed curve formed by line segments. Choice C is a curve formed by line segments and that does not intersect with itself. Okay. Choice D is a simple closed curve formed by line segments. A simple closed curve formed by line segments. Clearly, the answer is choice D. That is the what is a polygon? We know that a polygon is a closed curve formed by line segments, but that curve should not intersect with itself. So a curve that does not intersect, a closed curve that does not intersect with itself is a simple closed curve. And of course, the polygon is made up of line segments. So this is a conceptual or theoretical question. Choice D is the correct definition of a polygon, that is a simple closed curve formed by line segments. Any other choices does not completely give a complete definition of the polygon. For example, choice A curve formed by line segments. No, that curve should be closed curve, and also it should be simple closed curve. Similarly, choice B, it says a closed curve formed by line segments. No, that closed curve has to be simple, that is, it should not intersect with each other. Choice D says a curve formed by line segments and that does not intersect with itself. That is fine, but the curve should be closed. A curve does not, simply saying a curve, we do not know whether it will be open, it can be open or closed, but a polygon is always a closed curve. So choice D is the correct definition of a polygon. Let's do question number 3. Question number 3 says that P and Q are two regular pentagons whose side lengths are in the ratio P is to Q. Then the ratio of their exterior angles is. P and Q are two regular pentagons. So pentagons means the sides is, number of sides is 5. Number of sides is 5. It is asking the ratio of their exterior angles is. Now we know that if I consider E to be the exterior angle of a regular pentagon, we know that first of all a regular polygon will have all its exterior angle equal. That is, each of the and if I say E to be the each angle of a regular polygon, we know that E is always 360 by n degree, where n is the number of sides of the regular polygon. Now, so for a pentagon, it is given that P and Q are two regular pentagons. Both P and Q are pentagons. For a pentagon, we know that for a pentagon, irrespective of irrespective of their side lengths, we know that for a pentagon, E will be equal to 360 by n will be 5, since a pentagon the number of sides is 5, this much degree. This is equal to 72 degree. So for a pentagon, that is any a regular polygon having number of sides 5, any regular polygon having number of sides 5 will have exterior angle as 72 degree irrespective of the length of its sides. So the catch is that the exterior angle is not dependent on the length of the each sides of the of a regular polygon. It is always dependent on the number of sides of the regular polygon. So clearly we will have that if E1, if I consider E1, if I consider P to be the exterior angle of polygon of the regular pentagon P, then EP will be equal to, and if I consider EQ to be to be the exterior angle of the regular pentagon Q, obviously both EP and EQ will be same equal, and they will be equal to 72 degree, because 72 degree is the exterior angle for a regular pentagon. So clearly we can see that EP is to EQ will obviously be 1:1. So the correct choice is C. C is the correct choice. This is so this was a little this question was purely based on conception. There was no calculation needed. Okay, let's see question number 4. Let the quantities E and N represent the exterior angles and number of sides of a regular polygon respectively. Okay, so what is E to be the exterior angle? Exterior angle of a regular polygon, and N to be these two quantities E and N. E is representing the exterior angle of a regular polygon, and N to be the number of sides of the regular polygon. Now it is asking then how are E and N related to each other? The choices are, choice A is E varies directly with N with constant of K is constant of proportion with constant of proportion as 1 by 360. Choice B is E varies inversely as 1 by N with constant of proportion being 1 by 360. Choice C is E varies directly with N and K 180, and D is E varies inversely with 1 by N with K equals to 360. Now we know that for a regular pentagon having n number of sides, if E is the exterior angle, then E is equal to 360 by n this much degree, or this can be written as 360 degree by n. Clearly we can see that E into n is equal to 360 degree. This is a constant. 360 degree is a constant. So we see that E into n, the product of the quantities E and n, is a constant. So definitely we can say that this will imply that E will vary inversely with n, and of course the constant of proportion will be 360. So this was also a very conceptual problem based on the formula of based on how the exterior angle, each exterior angle of a regular pentagon and the number of sides of the regular pentagon are related to each other. So the correct choice is D. D is the correct choice. Okay. Let's do question number 5. Let E and I be the exterior and interior angle of a regular polygon P. If P has 54 diagonals, then the ratio E is to I is. So P is a regular polygon, okay, and it has 54 diagonals, okay, and it is asking, and E and I are the exterior and interior angle of the polygon P. It is asking about the ratio of E and I. Okay, we know that for a diagonal, for a convex diagonal, for a convex polygon, for a convex polygon, or maybe I think it did not be a convex polygon. It can also be a concave polygon. So for a polygon, we know for a polygon of, we know the formula for the number of diagonals of a polygon of n sides. For a polygon of n sides, we know number of diagonals is equal to n into n minus 3 divided by 2. Okay, so if n, capital N, is the diagonal of this polygon P, then we have, it is given that the number of diagonals of this polygon P is equal to 54. So we have this. From here we have to find out what is the value of n, that is the number of sides of the polygon P. From here we get n into n minus 3 is equal to 54 multiplied by 2, which is equal to 108. Now we have to from basic fundamental basics of arithmetic, we have to create two factors of 108 so that the difference is 3, because the left hand side is n into n minus 3. N is a natural number, and of course for a polygon n has to be greater than or equal to 3. So n is any natural number greater than or equal to 3 such that n into n minus 3 is equal to 108. Now this should come from basic concepts. I can so you must be able to create two such factors of 108. So this will be you can 12 into 9. So 12 into 9, if you consider the difference is 3 and the product is also 108. So this 12 into 9, we can say this is equal to 12 into 12 minus 3. So clearly we can see that n is equal to 12. So the number of sides of this polygon P is 12. Okay, so we got the number of sides. Now it is asking about the ratio of E1 E is to I. So where E is the exterior angle and I is the interior angle. Okay, so for a regular polygon of n sides, we know that E will be equal to 360 by n, this much degree, which in this for this polygon P we have n is 12, so 360 by 12, this much degree, this is equal to 30 degree. Instead of finding the values of E and I, we can also do it this way. I think there is a better way of doing it. We know that E, the exterior angle, each exterior angle of a regular polygon is 360 by n. For the sake of I am ignoring the degree symbol. I hope you will understand. So E is this, and each interior angle is, we know, as per the formula, 180 multiplied by n minus 2 divided by n, where n is the number of sides of a regular polygon. Okay. Now clearly, for any a regular polygon having a number of sides as capital N, we can see that E is to I will be equal to 360 divided by N is to 180 N minus 2 divided by N. So this is equal to, if we convert the ratio as a fraction, this will be 360 by N this whole divided by 180 to N minus 2 divided by N. After simplification, this becomes 360 divided by 180 multiplied by N minus 2, and after further simplification, this will be 2 by N minus 2. So always remember that the ratio of the exterior angle and the interior angle of a regular polygon of having n sides is equal to 2 by N minus 2. Okay. Now we know that we have already found, so we just need the value of n to find the ratio. We already know that n is 12. So this will be, so E is to I will be equal to 2 by 12 minus 2. This is 2 by 10. This is 1 by 5, which in the ratio form is 1 is to 5. So 1 is to 5 is the correct is the ratio. So the correct choice is C. So this brings to an end in solving the first five set of good problems on the chapter of polygons. I hope these problems will give you a good practice of your understanding of the concepts of polygons. And so if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Now there will be a lot of more videos coming, a lot of more problem solving of 5 good problems on this chapter of polygons in the future sets. So please stay tuned for more of this kind of 5 good problems on this chapter of polygons. And also parallelly, I will start the next chapter from the textbook of author R.S. Agarwal, which is, I guess, quadrilaterals, in the other playlist, that is CBSE Maths 8 R.S. Agarwal. So I will end the video here. Thanks for watching, and until the next video, take care and bye.